Hi, and welcome to this class. In this video, we shall be talking about circle theorems. Alright, don't forget in my previous video, I explained that circle theorem is just all about you finding the angles in a cycle. That's just it. So it's basically all about you finding the angles in a cycle. But in order to be able to solve any given questions, there are some certain theorems you need to follow. In mathematics, it's all about the rules. Once you follow the rules and you get it right, you'll be able to solve any given problems. You get now? All right, let's go start. Now, the first thing I'm going to be talking about the tangent of a cycle. You understand? Because I realize that many of us we are familiar with the tangent of a cycle and we think it's something that is very difficult. It's not at all. Now, let me quickly explain what the tangent of a cycle means. Now, this is a cycle now, and let me just quickly do something here, right? All right. Now, what's the tangent of a cycle? A tangent is a line that passes the outside of a cycle. That's just it. A tangent is a line that passes the outside of a cycle. As you can see this line that we have here now, that's what the tangent of the cycle. You can see even if, as it passes the outside of the cycle, it touches, part of the word circumference of the cycle. It touches the body, part of the body of the cycle, right? So that's what they call what a tangent. A tangent is a line that passes the outside of the cycle. All right, let me do one more thing again. What are the things we need to know about the tangent of a cycle? Let's quickly talk about it now. The first thing we need to know about the tangent of a cycle is this when it comes to cycle theorems. Now, let's say we have a center of a cycle here now. You understand what I'm saying now? Let's say we have something like this, a line at the center. Yeah. All right. So whenever the tangent is being touched by a radius, whenever the tangent is being touched by a radius, this is the radius. This line is coming from the center of the cycle. Don't mind my drawing. Okay, I think it's okay like this. It's a bit at the center. All right now. So whenever a tangent is being touched by a radius, you understand what I'm saying now? It forms an angle 90 degree. It forms a what? A right angle. That's one thing you need to know about tangent. It's all about you knowing something and you'll be able to like say something about what you know. When you know, for example, now you know an artist. Now let's say you know Nicki Minaj. You can easily talk about Nicki Minaj. Okay, Nicki Minaj, this is the kind of song she's into, and So when you know something, try to know some properties about that person. For example, now everybody knows Michael Jackson. He's a dancer. You can say a lot about Michael Jackson, maybe due to his skin color or whatever. So this is cycle theorem now, and I'm talking about a tangent now. I said a tangent is a line that touches what the way a line that passes outside of a cycle. You understand? That's a tangent. A tangent is the line that passes the outside of a cycle. All right. And I said, okay, what are those things I need to know about tangent? The first thing is what I said. Whenever a radius touches a tangent, it forms a 90 degree. That's just it. It forms what an angle 90 degree. All right. What are some other things again we need to know about tangent? Let us talk about it now. All right. Let's say we have another cycle here, right? And let's see, I'm gonna draw this now. Hey, sorry, this is out of it. Let's say we have something like this. We have a tangent, something like this. Yeah. Let's say we have another one here. Hey, it might not be equal. Oh, no. Just watch. Okay, I think I got it right now. Okay, let me try to erase some part of it. Alright, so now this is what I want to talk about now. You can see now we have two tangents here now. We have these two tangents here. So I'm going to call this one, I'm going to call this my A, I'll call this my B, and I'll call this my what? My C. So what do we need to know about this now? The length of the tangents are the same. When you have, the length of two tangents are the same. This length AB is equals to what? Length what? AC. Oh, that's cool. Now we know something about tangent, right? Let's quickly recall. I said the other time that a tangent is a line that passes the outside of a cycle, which is this line that passes outside of the cycle, and it's also touched the part of the cycle, right? And the second thing I talk about the tangent is that what when a radius touches the tangent, it forms an angle 90 degree. You understand? Something like this, and we have a tangent here, and this is a radius here, and when it touches the tangent, it forms an angle 90 degree. That's what I'm saying. All right, now let's move on now. All right, the first thing we're gonna be talking about today, we are gonna be talking about semicircle. Oh, cool. We already know something about tangent, right? Let's go and meet Mr. Semicircle. When it comes to cycle theorem, what do we need to know about Mr. Semicircle? I'm just trying to introduce you to the board members, right? So we have Mr. Semicircle in the house. All right, everybody knows a lot about semicircle. Semicircle is just like it's just half of a cycle. You know that when I divide this cycle into equal half. Sorry, let me delete this. When I divide this cycle into equal half, one part of it is half of a cycle. So the other part is also half of the cycle. So they form a complete cycle. They call them what? Semicircle. All right. Fine, it's cool, it's nice. So what do we need to know about Mr. Semicircle? What do we need to know about the semicircle? All right, now as regarding these cycle theorems now. All right, what I want to say about this thing is not much. All right, I just want to tell you that what in a semicircle, the angle formed in a semicircle is equals to what? 90 degree. Please let's note that. I'm trying to explain the theorem. Let me even call this one the theorem 2 because I already talked about the first one yesterday, where I talk about a line that bisects a chord and it forms 90 degree, right? I'll call this on my theorem 2 now. All right. So now what we're talking about now, a angle drawn in a semicircle is equals to what? 90 degree, regardless of the position. Let's say we have something like this again. Even if you have the angle to be somewhere here, wherever, it is still 90 degree. Alright, let us quickly do a proof of that, because whatever I'm going to be talking about, we are going to be proving it out so that we can get it better. So don't forget the theorem now. I said what? The angle in a semicircle is equals to 90 degree. Please note that. Without this theorem, you cannot solve any problem in this question, in this topic you get now. So let's quickly prove this. Why is it that the angle formed in a semicircle is 90 degree? Let's prove it. Alright. So let's talk about it now. Let's say this is a cycle, and I have my circle divided into two, right? So fine, it might not be equal, please just remind me. All right, now, so let's say we have a triangle here now, and we also have another triangle. Let's say we have a triangle here, and we also have another. We have a complete triangle here in this semicircle. They are equal. Please don't mind me. I mean, just don't mind the diagram. All right, now. And to prove this now, we are going to do just simple thing. We are going to divide this cycle. This triangle. We divide it into what? Into two. No. Yeah, let's just manage it. Okay. We divide this triangle into what? Into two. You understand it now. So I'm going to label it. Don't forget, once you divide this angle into two now, do you notice something? It forms two isosceles triangle. So this one and this one, they are equal. You understand? And it's also form an isosceles triangle with the other one too. You understand it now? So and there's one thing you need to know about isosceles triangle, and which is what? The base angle of an isosceles triangle they are equal. Yeah. The base angle of an isosceles triangle are what? Are equal. So let us try to label this angle. I'm going to label this one. I'm going to label it X. I call this angle X. Sorry. I call this angle that is here, this small one, I call this what? X. And because this one is X and is the base of this isosceles triangle, it makes the other one to become X as well. So this one will be X. Alright, so and let us label the second part now. Let me finish labeling this one now. Let me call this angle that it's always three angles that we have in a triangle. I'll call this one what? I'll call this one A. Sorry, I call it what? A. You understand? So in this first part of the triangle now we have 2x and A, right? Okay, now let's talk about the second triangle. Let's label that one with a separate ink color. I'm going to label this one, let's label it my Y, and I'm going to label this one, let's label it W, and then another W. You understand it now? So fine, I'm going to prove the reason why the angle formed in the semicircle is equals to 90 degree. So let us talk about it now. Alright, what we need to do is this now. Let us quickly talk about it now. In the first triangle, we have x plus a will give us 180 degree, right? Which is what? Let me quickly write it here now. X plus a will give us 180 degree. Please always write your reason. The reason is because what? The sum of the angle in the triangle is equals to 180. I might not be able to write it because of time. You know, I want to keep this video very short. But always write your reason. That's one of the steps to follow when doing this kind of work. You understand? You always write the reason for whatever you do. All right. So x plus a is 180 in this first triangle. Why? Because the sum of the angle in the triangle is equals to 180, right? In this first one alone, we're gonna have what? 2x plus a is equals to 180. Please, I'm going to call this one my what? Equation 1. Wow, that's cool. That's cool. We got an equation. All right, equation 1. Let's form another equation from this thing now. I can still form another equation, right? So in the second one, I can easily say w again plus w plus y again is equals to what? 180. Why? The same reason, right? Because what? The sum of the angles in the triangle is equals to what? 180. All right. In that case now, so you know I'm going to have 2w, and w plus w give us 2w. So 2w plus y will give me what? 180. I'll call this one my what? Equation 2. All right. So, and I can also form one other equation again. All right. I can form another equation again, right? So let's form the other equation. Let's form the other equation, which is what? A plus y. You understand? These two that we have here. A plus this y will give me what? 180. With a different reason. Why? Because the sum of the angle on the straight line is equals to 180. They are on the straight line. I'll call this on my what? Equation. Sorry. I'll call this my equation 3. Equation 3. Alright. So let me summarize what we have here now. In the equation 1, we have what? 2x plus a to be equals to 180. That's equation 1. In the equation 2, we have 2w plus y to be equals to 180. We call it equation 2. The equation 3, we have a plus y to be equals to 180. We call it what? Equation 3. Alright? We call it what? Equation 3. Alright, that's cool now. So what we're going to do now, let's try to solve it simultaneously, right? So we're going to add equation 1 to 2. You understand? We had equation 1 and 2 together, right? Let's quickly do that now. So we add equation 1 and 2. Alright? So by the time we had equation 1 and 2, let's see what we're going to have now. We're going to have 2x. We have 2x, right? Plus what? Plus 2w. Plus what? A plus y equals to what? 180 plus 180. I believe you get what I wrote here. Please let me write it clearly. Let me write it more tiny. Equals to 180 plus another 180. Alright? So in that case now, we're going to have right now, you're going to have what? 2x plus what? Plus 2w plus a plus y is equals to what? 360. That's the addition of what? Equation 1 and equation 2. You know now, the 2x will be added to the 2w, like the first part, like the a will be added to the y, and the 180 will be added to the 180 again now. So we're going to have what? 2x plus 2w plus a plus y equals to this. Don't forget now, this is what I added together. Oh shit. That's not what I wanted to do. Alright, you see, I added this one together. Let's just quickly go back to it now. So 2x plus 2w a plus y, a plus y and 180 plus what? Plus 180. So that's what gave us this guy. Alright, so what again do we need to do again? Don't forget something, please. Don't forget that what in equation, you always say from equation 3. Don't forget that what a plus y itself is equals to 180. All right. So you are going to substitute for a plus y in this particular equation. You get it now? Okay, now I can even call this one my equation 4. Save now. I can call it equation 4. I can call it my equation 4. So you substitute for a plus y in equation 4. Anywhere you say plus y, you put 180 because you know we have 2x plus 2w plus a plus y equals 360. So it's going to be equals to what now? 2x plus 2w plus anywhere you see a plus y, you put what? 180 is equals to what? 360. Please, if you don't know where I got the a plus y, let's quickly check now. Equation 3 is a plus y equals to 180 from here. That's what we got it. So just play back the video and you get it better. All right now. So let us solve it on now. We now have what? 2x plus 2w plus 180 equals what? 360, right? So that's what we have there. So in that case now, what are we going to do now? Let's do it. You send the other 180 to the other side. You collect like them, right? Let's leave the one that has the letter. Let's leave them to the side. So 2x plus 2w is equals to what? 360 minus 180. Are you there with me now? So in that case now, 2x plus 2w will be equals to 360 minus 180 is what? Is 180. Alright, that's cool. We can now factorize this one now. 2 is common. You say this one will be equals to what? 2 is bracket of what? X plus what? W, which is equals to what? 180. Alright, so what is my x plus w now? My x plus w will be equals to what? 180 over 2, right? Which is equals to what? 90. Are we making sense? 90 degree, right? So what is our x plus w in the question? I mean in the quadrilateral, in the semicircle. X plus w is this, right? X plus w that we have here is equals to 90. So that is the reason for that theorem. That what the angle in the semicircle is equals to what? 90 degree. Please let us take note of that, please. I'll call it on my theorem too because I already talked about like I even talk about these guys. They are also a theorem too, like you know. But let me just leave it like that. I call this one my theorem too. Okay, now. So that's all about that. Please let us move on to the next one, to the next theorem I'm going to be talking about. All right. Let me call this one my theorem 3 now. Okay. All right. This theorem is all about the angles at the center and circumference. It said that what? The angles at the center of a cycle is twice the angle at the circumference. Ooh. Let's draw this big cycle here. I won't waste the time. Whenever you have a cycle and you have something that looks like an arrow here, see this arrowhead here. You understand what I'm saying now? The inner angle here is twice the angle that is outside here. Ooh. Let's say this angle is B. The angle that is at this inner angle is 2 times B. It will be what? 2 times what? B. That's the explanation of this. Alright. Let's say we have something like this now. Let's say we have something like this now, and we have this one to be what? 55. Please, what will the inner angle here becomes? It will become what? Twice of this one, which is what? 110. So it said that what? The angle at the center here, this inner angle here, is twice the angle at the circumference. Please, let me draw it very so I can understand, because that my angle is not touching that cycle very well, and I don't like that. Don't mind me. Alright, so let's have it here like this. Alright now. So let's say we have these guys here now. This is what I'm talking about. You must touch it today. Or better still, I do something very cool. Let me do something very cool. Let's say we have a line here now. You understand it now. And we also have another line here. Forget the part that is touching outside. We have another one here. And we also have another one here, right? So now this looks like an arrowhead, yeah. So the inner angle here is 2 times the angle that is here. Okay, if this angle that is here is B, just know that this one is what? It's going to be 2 times B. That's what I was talking about. So let's say we now have this b that is here to be equals to 55 now. You understand what I'm saying now? The angle that will be here because what? Because what? 2 times b, which is what? 110. Note this theorem now. The angle at the center of a cycle, this angle at the center of a cycle, is twice the angle subtended at the circumference. Wow! How do we get this one? Let us quickly prove it now. Let us prove it. Alright, let's do a simple proof. I'm going to draw a cycle again as usual. I want to tell you the reason why it is like that. You know, we don't just say all these things, we have to learn how to prove it as well. And let me tell you something, please. It's very important for you to know how to prove these things. They might not have to prove in your exam, but once you play around with how to prove it, whenever they give you any question again, you'll be able to, manipulate with the question. Like, you'll be able to, do a lot of stuff with it. If you can learn how to prove it, that's why I'm making it as simple as possible. If you can learn how to prove it as well, don't just cram the theorem, also learn how to prove it. So that when they give you any question, you'll be able to solve any question. And I promise you, at the end of this class, you should be able to solve any given question on this cycle theorem if you can apply these rules, this theorem. You get now? Alright, now let's talk about it now. To prove this one now, alright, let me quickly draw it very well so that we can get it better. Let's see this thing now. I'm not writing because, please don't mind my diagram, please. It's not that, we can't compare this with. Alright, so let's talk about it now. Alright, so in this case now, let's see. I want to prove it, right? So if I want to prove this now, what I'm going to do is that, what I'm going to do now is this. I'm going to, okay, let's divide this triangle into 2. Oh, sorry, it's not at the center. Yeah, let's say we have 2 triangles here now. Alright, now, please let me label this now. You can see that as I divided this angle into 2 now, it forms, sorry, I just want to make sure that it's equal. I don't know why it's not touching it. Okay, let me start from here. Boom, boom, boom. Let's do something. I think it's better. It's not better. Better now, right? So you discover that in this angle you have divided into 2, and it forms 2 isosceles triangle. Wow, isosceles is very important too. Alright, cool. Let's quickly label the angle that we have here now. I'm going to label this big angle. Let's start from this one now. Let's start from this isosceles triangle. I'll name this one my x. And don't forget the base angle of an isosceles triangle, they are equal. I'll name this one x as well. Alright, let me name this other third angle of there. Let me name it A. You understand? So in the first part we have what? We have A, X, and X. The reason why the X is 2 is just because the base angle of an isosceles triangle, they are always equal. So, and if the value of this X is 2, the other one too will be 2, so they are equal. That's why I put X, so that we know that yes, we are talking about the same thing, right? Plus the other third one, which is what? A. Alright, let me name the other part of this one. Let me name this one. Let me name it let's give letter B, right? So this is my B now, and let's call this one let's call this angle, this one too is an isosceles triangle. We call it what? Y and what? And Y. Alright, okay, this one that we are trying to prove now, Mr. Chairman, this is what they call, let's call this one our C. We want to prove that this angle at the center is equals to twice the angle at the circumference. Let me write this C very well. It's not clear enough. Alright, so to prove that now, let us quickly talk about it now. The equation 1, let's talk about the first part of the triangle, the first triangle that we have here. We have what? X plus A, right? In the first one. Let's quickly do that. So X plus A will give me what? 2X plus A. I'll call it what? 2X plus A equals to 180. I'll call it what? Equation 1. Alright? 2x plus A is equals to 180. How do I get that? From the first part of the triangle, right? This one that we have here. The sum of these 2x plus A will give me 180. Why? The sum of the angle in the triangle is equals to what? 180. Always write it there. Alright, let's talk about the second equation now. The second equation is going to be what? Y plus Y. I'm talking about this now. Y plus what? Plus B, right? So this will give us what? 2y plus b, which is equals to what? 180. Equation 2. Alright? Equation 2, right? Let me write it very well. I think this guy is too big. 180 equation 2. All right. Okay, we can still form equation 3 from this now, right? The third one, let's form it now. We should be what? These guys that we have here. These guys that we have here, these three. As you can see, we have what? A plus B plus C, which is equals to what? 360. That's what? Equation 3, right? That's the sum of the angle meeting at a point. You understand what I'm saying now? So A plus B plus C will give us what? 360. Alright, it's very cool. Let us quickly summarize what we have here now. Equation 1 is what? 2x plus what? A is equals to 180. That's equation 1. Equation 2 is what? 2y plus b is equals to what? 180. Equation 2. Equation 3 is what? A plus b plus c is equals to 360. Why? Angle meeting at the point. The sum of the angle meeting at the point is equals to what? 360. So what are we going to do now? Let us quickly see what we want to do now. Okay? Let's see what we're going to do now. Alright, this is what we are going to do. In this case now, let us quickly make A the subject of the equation in this first part. So we have what now? A will be equals to what? 180 minus 2x. You get that? From this equation, from equation 1. Or let me quickly write it there. Okay? Let's go back here now. So I'll say from equation 1. What was that equation 1? Let's record equation 1. Equation 1 is what? Is 2x plus what? A equals to 180, right? So from that equation 1 now, the A will be equals to what? 180 minus 2x. Alright. Okay. Then again from equation 2, the B will be equals to what? 180 minus 2y. That's equation 2, right? Don't forget, let's go back to equation 2. No, B will be equals to what? This 180 minus 2y. I believe you get that. If you don't get it, please let me know. Alright, so I think this is enough for us to go. We are good to go now. So once we do this now we now go back to that our equation 3, which says A plus B plus C is equals to what? 360. Now, what's our A? Our A is what? 180 minus 2x, and our B is equals to 180 minus 2y. So let us substitute that now. So we are going to substitute for what? For A and B in equation 3. So this is what we're going to substitute A and B in equation 3. Okay, now. So this first part, equation 3 is what? This is equation 3, right? A plus B plus C is equal to 360, right? So anywhere you see A, we are going to put this value there. 180 minus what? Minus 2x, right? So that will be what now? 180 minus 2x. That's, we have A plus B. What's my B now? My B is what? 180 minus 2y, right? So 180 minus 2y will be anywhere I see B now. But we put it in bracket, please. Plus what? 180 minus 2y. Okay, plus C will give me what? 360. I believe you are going along with me. This is still your A plus this B here. We have it here. B plus what? This C will give me what? 360. Alright, so that's it now. So let us quickly do something to it. Let's do something to it. Alright. Alright, if you have something like this now, the next thing for us to do now is to expand our bracket and sum everything up and get our answer straight away. So we're gonna have what now? 180 minus 2x plus 180 minus 2y plus C will give me what? My 360 to give us 360. What again do we need to know? Alright, let us collect like 10, please. Let's collect like 10. So let's first sum this 180 that we have here up. 180 plus 180 here, this 180 here plus this 180 here will give me 360, right? So I'm going to be having what now? 360. Let's go back again. Then we're going to have minus 2x minus 2y, right? That's minus 2x minus 2y. What again do we have there again? That's plus C, right? Plus C will give me what? 360. Okay, that's cool. In that case, now let us collect like them. Like, let's send this 360 to the other side. We're gonna have what? Minus 2x minus 2y now plus C to be equals to what? 360 here minus the 360 that is there, right? 360. Alright, now. So we're gonna have what now? Minus 2x minus 2y plus C is equals to what? 0. All right, we are looking for our C now. So by the time we look for our C now, your C will now be equals to what now? This other guy, send it to the other side. We're gonna have what? Minus 2. I mean, it's gonna be what? Sorry, it's gonna be plus 2x now. Plus what? Plus 2y. Are you with me now? So you see now, when you send these guys to the other side, the sign is going to change to plus. So this minus 2x will become plus 2x. This minus 2y will become plus 2y. So your C will now be equals to what now? Can you see now? So C is equals to 2 in bracket of what? 2x plus 2y, which is what? C is equals to 2 in bracket of what? Of what? Of x plus what? Plus y. Now let us go back to our question. The angle at the center is twice angle at the circumference. Let's see if our 2 is equals to 2 in the bracket of x plus y. Okay, let's go back to our cycle. Oh shit. See our cycle. Can you see x plus y here? Can you see x and y? When you have x plus y here now, this C is 2 in the bracket of x plus y. That's why we say that the angle at the center is equal to twice the angle at the circumference. You get it now? X plus y. Can you see that this C now is twice the sum of this one, right? That's what we are talking about, and that's our final answer. All right, so that's it now. All right, let us move to the other theorem. I think that should be our theorem. What do we call this? We call this our theorem 3, right? So we are going to the fourth one now. Theorem 4 now. Let's talk about the theorem 4. Theorem 4. Okay, in the fourth one, what are we going to be talking about? What are we going to be talking about? All right, we are going to be talking about angles in the same segment. Oh, that's cool. Don't forget, in the last video or in the previous video, I explained what a segment is. You understand? Like, for example, this is a cycle now. If I divide this thing into 2, you understand? This is what? If I divide this into 2. In as much I'm not dividing with a diameter. If I divide the diameter now, it's going to form a semicircle, right? But it's even a segment. For me to divide this cycle into 2 now, this is a segment and this is another segment. You understand? This is what they call the major and the minor segment, right? So now, this time around now, we want to talk about the angles in the same segment. When you say segment, it can be in any form. I can have my chord to be like this now. And I also have, this is a segment, this is another segment. All right? So now, this is what we're going to do now. This is what we're going to do now. This is what we're going to do. All right. So let us talk about the angles in the same segment now. What's wrong with them? Let's say we have a chord here. Let's say we have a chord here now. I'm just going to do something like this. Okay, I think it's better. All right, now let's say we have sorry. We have something like this here. And let's say we have another line here, right? Okay, we have something like this here again. All right, okay, that's cool. All right, now you discover that this angle, I'm going to call this my angle A and B. You understand? The sum of the angle in the same segment. These angles here, I told you that this is one segment, and the whole of this cycle here, like this is another segment. So, but these two angles, they are formed in this major segment. Are you there now? So, any angle formed in the same segment, they are what? They are equal. The angle formed in the same segment are what? Are equal. So, this A is equals to what? Is equals to B. And I'm going to prove that for you. Let us quickly prove that, please. So if I'm going to prove this for you now, it's very simple. To do that now, I'm going to, I love this, my triangle. Let me quickly, I love this triangle. All right. So let's do something. I just want to do this. All right. Let's say we have something like this now. Another cycle now, so that we can get it better. I want to prove the reason why the angle in the same segment are equal. Let's see if we actually making sense. All right, so let's say we have another line right like this. Let's say we have something like, I just want to prove it, right? We have something like this. Oh, sorry. Oh, no. We have something like this, and we have something like this, and we have something like this. All right. To prove that what this A is equals to B, what are we going to do? To prove that the A is equals to B, A here is equals to angle B, what are we going to do now? Let's use the normal rule that we have been using before. Alright, let me just try to extend. Let me try to draw this triangle again now. And let me try to make this one. Okay, let me draw another triangle here from the center. Let's say we have another triangle here now. And we have another, yeah, it forms another triangle with this black one that is here. You understand what I'm saying now? So by the time I do this now, and this is the center of the cycle now, I call this what the C. You understand what I'm saying now? Now I said the other time that the angle at the center is twice angle form. You can see this. This is also an angle form at the circumference of it, because this angle is touching the circumference. You understand what I'm saying now? So the angle C that is here, this C is equals to what? 2 times the angle that is here, which is what? 2 times B. That was the theorem we proved the other time. The angle at the center is equal to twice angle at the circumference. So this C is equals to 2B now. So in that case now, the C also is also equals to what? To 2A. So in that case now, if 2A is equals to 2B, what happened? Divide both sides by 2 now, by 2. So you see that what? A is equals to, sorry, by 2. You understand? In that case now, you see that what? A is equals to what? B. A is equals to what? B. So angle formed in the same segment are what? Are equal. That's another theorem I want you to know. That's theorem 4, right? The angle in the same segment are what? Are equal. Just note that, and that's the proof. Alright, you can just replay the video so I can get it better. Alright, let us quickly move to theorem 5 now. Alright, theorem 5. What do we need to talk about? Okay, let us talk about this now. We're going to be talking about the angles in a cyclic quadrilateral. Okay, let me draw a better one, because you guys are special. So let's draw a better one here. Okay, what I mean by cyclic quadrilateral, like a kind of quadrilateral that is drawn in a cycle, and all the 4 vertices are touching the cycle, like touching the circumference of the cycle. Like for example now, let's say we have something like this now. Let's say we have something like this. Okay, let me draw something like this here. Okay, something like this here, something like this, and again something like this. All right. Let me. It's not going to come outside, please. Please let me just, don't mind me. Let me just try to clean this thing a bit. Okay, I think I'm good to go. It's not, nothing is coming outside. Yeah. All right now. So now this is what we mean by what? By a cyclic quadrilateral. You understand what I'm saying now? So what do we need to learn about them? Now, the opposite angles in a cyclic quadrilateral are equals to what? 180. The sum of the opposite angle in a cyclic quadrilateral is equals to 180. The sum, if you have A here, if you have A here and you have this one to be B, A plus B will be equals to what? 180. That's what you need to know now. The sum of the opposite angle in a cyclic quadrilateral is equals to what? 180. Please let us know this very well. Once you know all these things, we are good to go. Alright. So let us talk about it now. The sum of the opposite angle in a cyclic quadrilateral is equals to what? 180. Even if you have something like you have C here, you have D here. So definitely C plus what? D also will be equals to what? 180. Alright. I won't tell you something without showing you my proof. Let us quickly prove it. Alright. So let's get started. Alright. I want to prove the reason why the sum of the opposite angle in cyclic quadrilateral is equals to what? 180. Alright, let's talk about it now. Let's say we have something like this. Okay. Alright, I have something like this and I have something like this. Please don't mind this diagram. It might not be as perfect as possible, but just, you get what I'm saying, right? Yeah, this thing is equal, okay? So right, to prove this now, this is what I'm going to do now. You know, let's say you have okay, let me quickly do something now. To prove this, I'm going to draw another angle here now. Okay, that's how I'm going to prove it now. You can see I can also form another angle here now. Okay, in this case now, like I want to prove that what this A and this 2B, I want to prove that A plus B is equals to 180. That's what I want to prove, because I said the sum of the angle in the cyclic quadrilateral, the sum of the opposite angle in a cyclic quadrilateral is equals to 180. So I just want to prove it now. I want to prove that A plus B is equals to 180. Let's do that now. Okay, now what we need to do is this now. Don't forget that if I have an angle at the center here, the angle at the center here, this angle at the center here is equals to what? It's going to be equals to what? 2 times A. Why? Because I said the angle at the center is equals to what? Twice the angle at the circumference. So this angle at the center here, if there's an angle here at the center here, it is going to be equals to what? 2 times A. Are you there with me now? Okay, fine. So I'll call this one my what? My 2A. Please let me erase this thing so I can get it better. Let me erase this thing so you can get it better. It's too big. It's too big. I call this one my what? My B. My B. All right. So let me do something here now. So this angle here now will be equals to what? 2A. Yeah, because angle at the center is what? Is twice angle at the circumference. All right. And again, we can also have another angle here because this one is the internal angle to this one that is here. So I call this one what? This angle that is here, this internal angle that is here now will be equals to what? 2B, because angle at the center is twice angle at the circumference. This angle here is the internal one of this one. It's the one that subtends this one, and this one is also the one that subtends. You know, when you turn it upside down, you look at it like this now. This one is like the internal one of the other one. Okay, fine. I think my phone is even rotating anyhow. So this is what I'm just saying now. The angle here now, this center now, is twice this one that is here, because according to the theorem now, the angle at the center is twice the angle at the circumference, right? So this one at the center will be what? It will be twice of this A. And this one again is the center of the B. So it will be what? Twice of the B. In that case now, let's quickly do something that is very funny. You know that this 2A plus 2B will give me 360. 2A plus 2B is equals to what? 360. Why? Two of them are you can sum it together to be angle meeting at a point, which is equals to what? 360. The reason is because the sum of the angle at the point is equals to what? 360. So 2A plus 2B is equals to what? Let me write the 360 very well. 360. You understand it now? 360. You understand it now? So if 2A plus 2B is equal to 360, let's go on now. Then what we're gonna have now? 2A plus 2B is equal to 360, right? So you're going to have 2 into bracket of what? A plus B equals what? 360. Alright? So in that case now, you know that A plus B will be equals to what? 360 over 2. So your A plus B is equals to what? 180. Can you now see that what? This A, the sum of A plus B will give us 180. That's why we prove it that what? A plus B is 180. The sum of the opposite angle in a cyclic quadrilateral is equals to what? 180. So that's just it. Alright, let me talk about the theorem 6. And by now I've talked about 8 theorems, because I talked about the tangent as well. It's another theorem on its own. And I also talk about the midpoint the other time in the previous video. Alright, now let's talk about the theorem 6 now. Alright, and this time around I'm going to be talking about the alternate angle theorem. Alternate angle theorem. What do we mean by that? Let's move on. Alright, alternate angle theorem. Okay, it's very simple as well. Alright, let us quickly look at this now. Let's say we have a big cycle here. We need to be able to know all these things, know them by their properties, okay? So let's talk about it now. Let's talk about it. When is it alternate? When is it alternating? Like, how do we even get to know that? Alright, let's say we have something like this here. Let's say we have something like this here, for instance. And again, we have another line here. Yes, and a line here. Alright. So, okay, I think I'm good to go now. For you to talk about alternate angle, it must have a tangent too. A tangent must pass through this cycle. I believe you already know what a tangent means, right? You see a question like this, right? So let us quickly talk about it now. I'm going to label this guy. I'm going to label it. I call this now. If I call this on my A, I want to tell you that what alternate angles are equal, right? So that's what we talk about, the alternate angle theorem, right? So this guy that is here, I'll call it what my B. The whole of this guy, the whole of the angle that is there, this angle that is there, I'll call it what my B. You understand? So what I want to say is this now. This B is equals to this A. This B is alternating toward to this A. You understand it now? This B is alternating toward to the A. You understand what I'm saying? And they are equal. And I can also say that this one, this angle that is here, that we have here, is also alternating to the angle that we have here. I call this one, if I call this on my, I can call this on my C. I call this on my C, I call this on my D. They are also alternate and they are equal. So for you to be able to identify alternate angle when you're talking about the alternate angle theorem, the one that is there, any angle that is formed here is alternate to that is formed with the tangent here is equal to the what an alternative to the one that is here. So when you have the value for your B is 5, then that your A that is there is going to be 5. Alright, I always like to prove whatever I see. Let us try to prove if this one is equal to this one. Alright, okay, let's talk about it now. Let's talk about it. Okay. Alright, so let us talk about it now. So I'm going to get something like this done. Alright, so I want to prove that this A that is there is equal to the B that is there. But don't let me forget my tangent. That's a shaman. Alright, so I'm going to get something again. Let me quickly try to label it as we have in the previous one, right? So I just want to label it. Don't forget I said this one is alternating to this one, right? This is B, right? So I want to prove that they are equal, right? I want to prove that they alternate to each other and they are equal, right? So for me to do that now, let me go do something now. I'm going to what? I'm going to do something now. Let me use red here now. Get this guy. Alright, I'm going to draw another angle here so that we can get it better. Pam. I'm going to draw another angle here just to prove. Pam. Alright now. So in this case now, what am I going to do now? Now, it's very simple, right? Don't forget that this angle, this red line that is there, is dividing this cycle into 2 equal half 2, right? Which is very nice, right? So I can now label. Let me quickly label this guy. Let me label it so I can get it better. I'm going to label this one. I'm going to label it C. Sorry. I'm going to call this one C. Oh no, let me use another ink so that we can get it better. I'm going to call this one C. You understand what I'm saying now? The new triangle I just draw, I'm going to label it C, and let me label this one. Y. Okay. Oh, plastic. No, let me label this one. Okay, cool. I'm going to label this one A. Somebody tell me why. Do you know why? Because if you look at this diagram now, 2 of them, they are now in the same segment, and that was the theory I explained earlier. Where I said angle in the same segment are equal. They form in the same segment, they are equal. A is equal to B here. This angle is equal to this angle that is there. So in this case now again. So I'll call this one my A again because it's equal to the A that is there before. They are both on this segment now. This part, this other part, the whole of this part. They're on this part. So they're on the same segment. So this A here is equal to what is here. That's why I made it to be A. A and A is even good like that. So they are equal. So if I label it on my A, what again do I need to know again? Don't forget something I told you last time that what the angle formed in a semicircle. By the time you decide to cover the first part of this cycle, let's say I just want to cover all this one that I have here. I don't want it again. Do you know that this other part is a semicircle? Now, and I told you that time the angle in a semicircle is equal to what? 90 degrees. So this one is 90. If this one is 90 degrees, we are good to go now. Don't forget that if this one is 90 degrees, this A plus C will also be 90 degrees because what? The angle in a triangle is equal to 180. So if you have A plus C now, if A plus C plus 90 will give you what? 180 degree, right? So A plus C will be equal to what? 180 minus 90, right? So A plus C is equal to what? 90. This is what I need. You understand what I'm saying now? So this A plus this C is equal to what? Is equal to 90. Alright. So if A plus C is equal to 90, do you also know that what? This guy that is there, I said whenever, let's say we have a point here now. For instance, now let's say you have a point. This is the center, right? So from here to here now down to this place, it's as if a radius is touching this tangent. And I said whenever a radius is touching the tangent, it forms an angle 90 degree. You understand now? Which tell us that this C plus this B that we have here is also equal to what? 90. Hello. If A plus C is 90 and B plus C is 90, let us try to subtract both equation, right? If you have this one as your equation 1 and this one as your equation 2, equation 1 and equation 2, you know that what it's going to be what now? A plus C, okay, it's going to be what? A minus what? Minus B, then plus what? C minus C, which is equal to what? 0, right? 90 minus 90 is 0. Then you know that what now? A minus B will now be equals to what? 0, right? Then A minus B now, in that case now, A is equals to what? B. Okay, don't let me rush it. Let me try to move to the next line so that we can get it better. So I said, in this case, A plus C is equals to what? 90. How do we get our 90? Because from the first story we talked about, I said any angle from the semicircle is equals to 90. So that's why I get to know that this angle that is there, is 90 because it's in the semicircle. If you should look at it from this other part here, the semicircle with this one that is there. So now that's why I get to know this angle is 90 degrees because it's like a triangle formed in the semicircle. Okay, fine. So if this is 90, if it's 90 degree now, and I get to know that what by the time I sum this A plus this C again with this 90, they must give me 180 now. So and I know that what okay fine, this A plus C plus this 90 will give me 180. I know that what A plus C will now be equals to 180 minus 90 when I collect like 10. So that's why I know that my A plus C will be equals to what? 90. If my A plus C is 90, then I also know that what this my C plus B is 90. How do I get to know that? Because I know that what according to the theorem that explains the tangent. I said whenever it's a radius is touching the tangent, it's going to give us angle 90. And this is like when you divide this into two, like from the center now, this is like a radius touching this tangent here, and it's going to give us 90 degrees. So C plus B again will give us 90. So by the time we have A plus C equals to 90 as equation 1, and we have what C plus B equals to, is it C plus B? Sorry, is it C plus B? Yeah, C plus B equals to 90 again in equation 2. So by the time you do this thing now, we get a minus equation 1 from equation 2. Subtract equation 1 from 2. You get what? You get have what now? A minus B plus what? C minus C, right? Is equals to 90 minus 90. Abi? Which is what? A minus B is equals to what? 0. You get now? Because C minus C is also equals to 0. So if you have A minus B equals 0, do you know that what? A is equals to what? B. So can you now see that what this A that is there is equals to this B that is here? You understand now? So the alternate angles theorem, they are always alternate angles are always what equal. So how do you identify the alternate angles? What I said. So when you have something like this now, you know that this B is alternating to this A that is here, and this C is also alternating to this D that is here. All right, see you in the next video. Thank you so much for watching. Bye bye. And if you have any questions, please do hesitate to drop your comments. Thank you.